we're just going to talk about the general idea about how to find the area caught between two curves over an interval. So here I've graphed y equal f of x. So in a specific problem you have your equations and you want to graph them first. That's a key component of this process. So I've graphed y equal f of x and y equal g of x. And then x equal a, we draw a vertical line there, and x equal b, we draw a vertical line there. So the region that we want to find the area of is caught between f of x and g of x over that span of x's. So this shaded region in black here. Now recall that the definite integral from a to b of f of x dx adds up all of the function values from the x-axis to the curve. So it would be from the x-axis all the way up to f of x. But that would be too much. That would give me all of this region, and I want just this region. So if I subtract off the definite integral from a to b of g of x dx, it'll be subtracting off all of the g of x function values. So from the x-axis to g of x. And by taking this overall orange shaded region and subtracting off the pink shaded region will give me the area of the region that I'm interested in. Now remember that with definite integrals, we had the property that the definite integral over an interval of f of x minus g of x dx could be written as the separate definite integrals. Well, that means that if we have the separate definite integrals, I can actually write that, as long as the interval that we're going along is the same, as the definite integral from a to b of f of x minus g of x dx. Also recall that if your function you're subtracting has more than one term, you need to put it in parentheses, distribute the negative through the parentheses to remove them before you do the antiderivative, and then plug in the a through the antiderivative minus plug in the b through the antiderivative. But doing that process, then you'll find that area between the curves. So again, you need to make sure that you graph these problems. You need to look at the graph and find out which function is consistently higher in the plane and which function is consistently lower in the plane. And when you're running your vertical subrectangles, you always want the definite integral of the function on the top of the region minus the function on the bottom of the region to find that area.